Hello and welcome to day 5 of how to get started with Solana Development in 2026. Today we're gonna talk about tokens because tokens are everywhere. You won't get around understanding what tokens are when you want to do Solana Development. So I really want to cover that topic in this series as well, especially also because tokens work differently on Solana than they do on other blockchains. For instance, on Solana, you don't need to deploy your own program or smart contract to create a token. Theoretically, you can, but that's not recommended. What I'm saying is you don't need to deploy a program in order to work with tokens. Of course, you can do whatever you want. I'm still not your mom to tell you what you should do. However, I will still try to give you good advice on how you could be doing things if you want to go the easy and most compatible way. Because what tokens are, essentially, coming back to our idea from day 1 with the ledger, here we just had one entry per wallet, right? So on Solana that would be Andy has some Sol, Anatoly has some Sol. But now we can also have tokens and they can represent basically whatever. For instance, they could represent a stablecoin like USDC. Then I can have Sol and USDC in my wallet. And there can be several tokens. I can have a stablecoin for Euro. I can have a stablecoin for Yen. I can have tokenized real estate. I can have voting tokens. I can even have fine art or art as an NFT. I can have some custom tokens that only mean something to a specific application. And all of that in my same wallet. So a token is really just a thing in my wallet that can represent something. It doesn't need to. I can just have a token that is just a token that I created myself. Not every token must represent something, but most of them do. That's where they get the use case from. No, actually, most of them are probably useless, let's be honest. But they still represent something. Something useless, maybe. That's opinionated. We don't need to go further. I'm pretty sure that you have heard about tokens if you're in crypto. And I would say that almost every single program in one way or another interacts with tokens, directly or indirectly. So that's why this is such an important topic. And that's why we're going to talk about it today. And maybe I should talk a little bit about why tokens are useful. So you can think of a token as something that we give to the user and let them have control over it, basically. So they can send it around, they can destroy it if they want, but it's really theirs. And so using the existing token program is really nice for us as developers because we don't need to bother about the functionality of the user being able to send that around and give it to someone else or whatever. We just represent it as a token and the functionality is already there. That's why so many programs use tokens, because you don't need to reinvent the wheel. So basically, you can think of a token as something that sits in a wallet and that can be transferred. By the way, you can also think of Sol as a token, just that it's the native token on Solana, so we don't call it a token, we call it a coin. But really, it's kind of the same thing. Sol, however, can be represented as a token, then it is an actual token. We would then call that wrapped Sol, because the actual Sol is wrapped inside a token, and that token we call the native mint. And I did make a video about wrapped Sol before, if you're interested. But yeah, today for the general case of tokens. We're gonna get more technical, but before we actually start talking about tokens, we need to have a look at the homework from yesterday. Did you do your homework? The task was to call the initialize instruction of the program that we wrote with the correct accounts, and one of them is a PDA. So the challenge was to find out how we can create this PDA. And we will need this for today's topic, because PDAs will come back for tokens as well. So we want to understand how we can derive them in the kit. If you haven't done the homework and you still want to try it, you can pause the video. That's the cool thing about having an asynchronous classroom like this. You can just pause. But otherwise, you can just check if you did it right or watch me do it. So we're going to basically do the same thing as we did last time when we called our program, except there we called the set. And yeah, actually I can keep that. Keep setting it to happy. But then I will need another instruction. So that's the set mood instruction, I will also need the initialize instruction. And for that, I will need to have the instruction discriminator. I could find that on chain or in the IDL of my program. Let's see, we do have the IDL. So you can look at the instructions and the instruction discriminator, and you can copy that. Or you find an instruction that does that. So this time it's in a different code. This time I'm actually giving you the uint8 array directly. Here you go. And then we just need to find the correct addresses. Also that I could find in the IDL or from looking here in my initialize accounts. We need the pair, the authority, which in our case is going to be the same thing. It's going to be my key pair. So we're going to create the PDA for this address. And we haven't created any PDA for this address yet, so that should work. So we're going to use twice my key pair address as a writable signer. For the authority, it wouldn't need to be writable, but it would need to be a signer still. But since it's the same address, it doesn't matter anyway. It's provided as a writable signer because it's both writable and a signer. And then comes the interesting account, the state account, which is our PDA with the keys state and authority. And then the system program. The system program should be fairly simple. We could even import that from Solana program system. It has the system program address, which is just a bunch of ones. So I'm going to use that. And then here goes my state PDA, which will not be a signer, but will need to be writable because you create it. And the system program is read-only, of course. Okay, and now the challenge is, how do we get that state PDA? And there is a nice function in GIL or in the kit, and it's called get program derived address, PDA. We're getting a PDA for a specific program. In this case, our program, we're going to save that address as our program. So provide that as the program address. And then we twice call that program. And then we will need to provide the seeds. But we also know what those are. We know it from the IDL, or we look here, state and the pub key from the authority or the address of the authority. So state, fairly easy, it's just a string. And then for the authority, this is a bit more complicated. So that's going to be my key pair address. But because the type in TypeScript here is a string and I want the actual 32 bytes, I need to get an address encoder and encode this address. So it takes the address and encodes it to bytes, because the bytes is what we'll need. And with the program address and the seeds, we get the PDA. Do we really get the PDA? No, we get the address and the bump seed. Because remember, the bump is that 1 byte that makes sure that the address is off curve, that is added basically additionally after the seeds here. But the get program derived address does that automatically. It adds a bump. It finds the canonical bump, it's what it's called, the first valid bump. And it will also return that. So we can save the PDA and the bump, even though we will not use the bump, but we're going to save it here anyway. Or we got to await this. And then I can put that state PDA in here, and also for the other instruction in here. And then it will also need my key pair. And with those two instructions, if I put them into a transaction and send that, that should hopefully work. Let's check it. So in Day5, npx_tsx, let's call that program and see, yes, look, the transaction got confirmed and it did what we expected to do. It does create that PDA. So that was the address that we got back when we did this. The state PDA, I could have logged it. If I just log, that's the address, just so you see. I returned here because I can't send the transaction again, because I can't create the PDA again, right? It is already initialized now. So that account got created, and then we even in the same transaction already set the mood for it to happy, and the account is now happy. Isn't that great? Cool. And with that knowledge of how to derive the PDA in TypeScript, we can finally talk about tokens. Let me get my green screen back for that. Let me get a pen, because I noticed that you can't really read this. Could even use colors. let's say each of those sheets represents an account, because everything on Solana is an account. So we have the token program. I really don't know why I use sheets and not do that digitally, but this is how I want to work today. Ow, I'm really going crazy now. I did not plan this. This is improvised. There we go. Token program. Amazing. The token program, that's the program that we're going to be interacting with. That's the program that has all the instructions that we need to do. So what can we do with the token program? Well, we can create a token. If we create a token, we create a new account that we call the mint. So with the token program, we create a token mint account. This represents the token. It might have metadata stored, like its name or the symbol of the token. This is what we mean when we talk about the token. And the address of this account is how we identify this token. This account also keeps track of how many tokens there are in existence, but it does not actually hold tokens. So let's go back to my wallet. That's ugly. You can't tell if it's my or Anatoly's wallet, right? Anoli, or maybe it's our common wallet. Anyway, so that's a wallet. Let's say my wallet. That wallet account doesn't hold the tokens directly because, as we said, wallets account are owned by the system program. So the system program owns this account, which means the token program couldn't even write to that. And also, we don't want to have all of the possible tokens in one account. That would be really bad for execution. So what we're doing is we're creating a token account for this wallet. So this is now Andy's token account. We create this account, and other wallets could have other token accounts. And also my wallet can have several token accounts for different mints. And even it could have several token accounts for the same mint. That's how we started out on Solana. But because that got complicated, because then you have some tokens here and some here, and then it just got a bit messy with those auxiliary token accounts. That's why we introduced another program, the associated token program, that will create associated token accounts. So now there will always be just one account per mint and wallet and token program, and not several. And guess how we do that? Through PDAs. So now this is my associated token account. Now to recap, with the token program, I can create a mint. Then with the associated token program, I create an associated token account. So the ATA is a PDA of the associated token program, but we give ownership of that account to the token program. And see, that's why it comes handy if you understand those concepts that we've been talking about in the previous videos. In case you don't understand ownership, authority, and PDAs, watch the previous videos first. And then it will have an authority of who can move those tokens, and that will then be my wallet. So mint is owned by the token program, represents the token itself. ATA references the mint, so it's a token account of a specific token and for a specific wallet. And this account here now actually contains the amount of tokens. So the actual tokens are in here, the amount. And if we send the tokens to another wallet, then we modify this ATA and the other wallet's ATA and move like we did with Lampert's, just now with tokens. And it's not the system program doing that, it's the token program doing that. And because there are not enough accounts here, there's one more caveat to this, which is that there is more than one token programs as well. One is the old one, token kek, the regular one with the regular features. And then we have a new one called token extensions that has some more features like being able to store metadata in the mint account and a bunch more extensions. I made a bunch of videos. There's a playlist on that up here. And we're not going to go into the details of the extensions today. We just want to understand that setup of accounts that are involved when we create a token, which are quite a lot. And that's just for one wallet with one token. And then obviously we'll have more in each direction. So yeah, this board is getting too small, and also my drawing skills are probably not the best. So let's move back to the digital age and actually look at that on chain. But just to quickly recap, the token program lets you create a token. So that's the initialize mint. With the associated token program, we create an associated token account. The mint account stores the authority who's allowed to create more tokens, the so-called mint authority. And with the token program, we can then mint tokens into a token account. Then we can also use the token program to transfer tokens between token accounts. The token program, or as I like to call it, token keg, because that's the address of the account where this program lives. That is the token program, which is the program that is used for most tokens. As I also mentioned, there's also token Z, the token 2022 program, because that's when they developed that. So yeah, those are the two main token, or the official token programs that exist on Solana. Obviously, anybody can deploy their own token program. It's just a question of compatibility with other programs. But the good thing is you don't need to create your own program. For most use cases, the standard token program, token keg, will be good enough. If you need special features like non-transferable tokens or metadata, confidential transfers, then you might want to work with token extensions, so the token 2022 program. But for today, let's stay with token keg, which will also soon be updated to be even more efficient, mentioned in one of the videos. I make a lot of videos, in case you can't tell. This is not my first rodeo. Okay, fun fact also, my first ever video was on creating tokens. That's how essential this is. And that's really then what got me hooked on Solana. Yeah. Good old times in 2021. Nowadays, we have several options how we can create our tokens. So let's go through this process and create ourselves our own token. There's many ways how we can do this. One is by using the CLI. If you have the Solana CLI, that comes with SBL token, which is its own command line utility that allows you to create tokens and do all that stuff with them. Now that's for both tokens and token extensions, that's why there's a long list here. But let's go through the most essential stuff, which is to just create a token. I can enter that command and it will create me a token under token keg, and that will be the address. So that's the mint public key, or the mint's address. In this case, it was a public key. And it will tell me how many decimals it used. Also that I could change with -- decimals and set it to 0, for instance. And really that would kind of be the same thing. It's just a question of how you represent stuff. 0 means that the smallest entity you can send around is one full token, and 9 means that you can send a billionth of a token. Like with Sol, think of Lamperts. You can think of Sol as a 9 decimal token. 1 Lampert is the minimum that you can send. And a token that has 9 decimals, the minimum that you can send is also 1 billionth. Or think of it the other way around. You need to add 9 zeros to get to the actual token amount. But that's really just important for UI stuff and how you want that token to be represented. Sometimes it makes sense to have it a 0 decimal token. Sometimes it makes sense to have it a 9 decimal tokens, which is the default. You can have everything in between and even above. But at some point it doesn't make sense anymore, because then you can only have so many total tokens. And I did make a video about that as well, which I will link up here, diving deeper into decimals. Not gonna spend all too much time here. So now we have created this token. We can look at that on chain. This is now the mint account. It's a token mint, as the Explorer says. But currently there are no tokens of that in existence yet. We created the token, but not the tokens. We didn't mint tokens yet. Also, one of the most important things that the mint account stores is actually the mint authority. Remember authorities? That's the account that needs to sign in order to be authorized to mint tokens. And when we say mint tokens, what we really mean is the create more tokens. But the creating a token, what we just did here with create token, that creates a mint. So it just creates one of that, hey, this is a token now. It's this type. It's basically the type, that token type. And then to create real tokens of that type of token, we mint. But before we can actually mint, we need an account to mint into. So we need a place where we can put the tokens. Because for now, the green one, that was just the account that describes the token. And then the yellow ones, that was the token account. That's where the actual tokens live in. You know, there will be several token accounts where the actual tokens live in. And to create one of those token accounts with CLI, I just say create account. It's that simple. I just need to tell it for which token. So Aspire token, create account for which token, and the rest it will figure out itself. So this is now my token account. The token account has an address because it's an account. Every account has an address. But the interesting part, as we will see later, is that that was derived. So that's actually a PDA, not a pub key anymore. The mint was a pub key in our case. We created a key pair. I mean, you can look at the transaction. What happened? The system program created an account. This was the new address. So this was actually a signer. We actually did create a key pair for this. But then we threw it away because after we create the account, we don't need the key pair anymore. And we will look at that in a second in more detail. The point I was making here is this is a PDA because in this transaction, that account is actually created through the associated token program, which does a CPI to the system program with create account. But now the new address is this one, and this one, guess what? That's why it's done with the CPI, such that this can be a PDA because we did not actually sign for that. But we know that the system program requires that to be a signer, so the only way this works is that that's a PDA. So yeah, that account is indeed a PDA, and it stores the mint, so it references back to the mint account. Which type of token is this? Is that field? And the owner, which is such a bad word. I keep complaining about this. It still didn't change. That's one of the legacy things that we still drag around, that we call this the owner. It's not the owner in the sense of every account has an owner. If we check Solana account for this account, the owner is actually the token program, because it's the token program that can write to this account. So the owner of the account is the token program. But what that really says is the transfer authority, or the authority, that should really say authority of that account, who is authorized to transfer tokens out of this account or burn tokens in that account. That is my wallet. Ignore that says owner. It's the authority. And then it also stores the token balance. So how many actual tokens do I have? That's the interesting stuff for us as a user. That's what my wallet should display. I have so many tokens of that kind. And then the status, which is initialized, which means that account is good to go. It's not frozen and it's not closed and it's not uninitialized, meaning there's nothing in there yet. And I already noticed I could make a 5-hour video just about token keg as well, because there are so many things that we could explore from here. For instance, we could have a look at how that's actually stored in the account just real quick, because that's a little bit of a spoiler for tomorrow. Tomorrow we're really going to talk about serialization and deserialization, because we're going to figure out that stuff that's stored in an account is not like this in a key value. It's really just a series of bytes. And if you really look at it, the series of bytes looks like this, where here is the mint address, here is the authority or owner, and then here is the token balance, and here is the status. But that's spoilers. Let's continue with our process of really creating a token, because for now we just created the type to actually get stuff into circulation or mint tokens. We can just say token mint. And then we need to say for which token. We have that information here. That's the mint. Then we need to say how many. Let's say I mint just one token for now. Actually, no, to showcase something, I'm gonna mint the minimum that I could possibly mint, the smallest unit of a 9 decimal token. And then I could provide the destination. If I don't, it automatically takes my ATA, so I don't even need to say anything more. That should work. And finalizing transaction. Boom. See, it did get the recipient address. That's my token account. It calculated that automatically because it's a PDA, so we can derive it. And now if I look into this account, I should see that I have 0.0000001 tokens. And if I look at the account in raw bytes, then I see here is suddenly a 1 because that's the amount of tokens that I have in the account. And the token balance really is just represented with a U64. So a 64-bit, so an 8-byte number. Okay, let's mint one entire token. Great. Then I have 1.00001 in here, or this number, which if you don't read hex fluently, might not be so easy to decode. But we still have the 1 here. If we don't like this 1 here anymore, we can also destroy tokens. That's the opposite of minting them. And that's also maybe an interesting thing to note. Anybody can just destroy tokens if they have the authority of a token account where tokens are in. And that would be with SBL token burn. And here, for some reason, I really need to give the token account address. I've been doing this wrong so many times that I now know that this really needs the token account and then how many we delete or burn. Let's go, burn them, and we're done. Refresh, and we're down to 1 exact token. And also here, down to just 1 token. And now the mint, if we refresh that, the current supply also says 1. So here it looks like as if there's always just been 1 token. The Solana state says there's just 1 of this token in existence. However, the Solana ledger knows, if we look at the previous transactions, that at one point there have been more tokens. Once again, to reference the difference between the ledger and the state. Because state is all the accounts. The accounts don't know historical data, but the ledger does. Okay, cool. And that's how you create a token. We have a token here. There's a few more features that the token program has that we didn't explore so far, like a freeze authority and then freezing token accounts, basically not enabling transfers or burns, even if you have the authority of the token account. If it's frozen, if the state is frozen, then you can't do anything with it, which is also an attack vector, by the way. But also for that, I made a separate video that explains that in detail. The one thing that I do want to still talk about and show you real quick is the most common use case for a token, which is to transfer it. Because as we said in the beginning, a token is just something that sits in your wallet that can be transferred. So let's do an actual transfer. It's super simple with SBL token transfer. And then we say which token. And then we say how many. How about half a token? I split my funds with Toli, who we want to send to. And since that person doesn't have an ATA yet, I also need to say I fund their account. So I fund recipient. That's just the CLI requiring that. And let's go. So the ATA for Toli would be this. We were funding that account as well. And we sent half a token to that address. If we check that account now, we see that it has half a token and Toli is the owner, the authority of that account. And now, really, half a token is forever lost because that account doesn't really exist and nobody has the key for that. But you know, that's what happens. People constantly send tokens to the wrong address for some reason and then complain to me that they lost it. So be careful when you send tokens around. You can't just do that and then not get them back, because as soon as you transfer them, you lose the authority. A transfer is basically just giving authority to someone else. Oh, there's also authorizing within the same account. We can also do that with the token program where we authorize another address to take some tokens of my account. And you can look at that as a homework, but it's outside of the scope of this video because it's not the basics anymore. And I still want to do something more with you because for now we've just used the CLI, which is boring. I mean, yeah, okay, does it take a dev to use the CLI? Not really, anybody can do that. For you to really understand what's happening here, I want to go through the actual steps. Because for one such transfer, look at that, we're using 9 accounts just for this little transfer. Okay, we also created Toli's token account first with the associated token program. So yeah, let's look at that in depth, what's really happening here. I mean, we got the basics down. I think you understand what tokens are. Now it's just about what are the real instructions that we need to call, what are the right accounts for the instructions, and what do we need to set up beforehand? Because that's also then important when you want to work with tokens inside your program. It's gonna be pretty much the same as here. But to get started, I just want to do it with the kit, and then you can transfer that to within your program as well. Really, it's not so complicated once you really understand what instructions you need to do, because then you just need to do the same instructions from within your program as a CPI. Okay, so let's go back to an empty. We're just sending a transaction script with our wallet. And like the system program, also the token program has its own package. We just need to install Solana program /token. And in here we have a bunch of stuff like the token program addresses in here as well, and all of the get instructions. So if we want to burn, a close, a freeze, initialize, and so on. And here it's really just important to know what are the correct instructions on the token program that we really want to call. Again, you could just do it with CLI and then look on the Explorer, or just watch this video, or just try it out and see what they do. But yeah, actually trial and error is really not such a bad idea. If you know you want to create a token, you just type create token and then see what could fit. Create associated token. No, that's not quite what we want because that creates a token account. We want to create a mint. Okay. Create mint instruction plan. Also not. But it has something to do with mint. Mint. Initialize mint. Maybe that's the right thing. But there's 2 initialize mints. So yeah, it would probably take you a while, and you're probably even faster if you just vibe code that as well. But you would get there, I think. That's usually how I like to do it. But yeah, I'm gonna tell you, what we need is the get initialize mint 2 instruction. 2, again, because we weren't happy with the first one apparently. And back then with the token program, we still just didn't do the naming so nice. The newer programs do that way nicer. Anyway, we just use that and don't ask questions. And then when we do that to create our initialize mint instruction, this thing will tell us what it needs. Anyway, it needs the mint, so that's the account, the decimals, and the mint authority. And optionally, we can, if we want, provide the freeze authority. Okay, so mint, that's gonna be the address of the account that we create. And there's a reason why this is called initialize and not create, because it just initializes that account and it doesn't create it. Also, if we have a look at the actual transaction of where our mint was created all the way an hour ago, here we also see that there's first a system program create account and then the initialize mint. Those two make up creating the mint, because we first need to create the account and then we initialize it. That's why this itself is not called create, because the token program itself can't create the account. Remember, we said every account is owned by the system program per default, so the token program first needs to get something from the system program. It could do that through CPI, but the way they implemented the token program is that this instruction already expects an account to be created for the token program as the mint, because that makes it more flexible as well. So we want to generate a key pair signer, which basically allows us to have a new key pair, a new random one. And then we put the address as the mint. Decimals, we can go with the default of 9. Mint authority, we're gonna use my key pair, and we're not gonna use a freeze authority. And that is enough for this instruction, but by itself does not work. Why not? Well, because that account doesn't exist. And then we get invalid account data for instruction. So we need to first already create this account with the system program. And that's just something that you need to know. That's why we practice it together. Create an account instruction. So we get create account instruction. That is also in Solana program system, and we just need to provide the correct things here. The new account that we create is our mint. The payer will be my key pair. So those are the two signers that we provide. The program address, so that will be the new owner of that account, will be the token program. The space, now that's interesting. If you don't know that by heart, there is a get mint size in Solana program token, the package here, that will give you a number, and that's the bytes of the mint account size. Token CAC has constant account sizes. Token extensions has variable ones, then you can enter the extensions in here as well. But for us, this is fine. And now we're just missing Lamperts, and that's once again an RPC request. Get minimum balance for rent exemption for that same size, and then send that. I did complain about that before. I will complain about that again, but at some point we gotta make it a big end. One of the pains. Whatever. I tried to fix it and I was told off. So it's just how we gotta do it. If you wanna work with a kit, that's how you do. Good. If we add that in front, so obviously we need to do the instructions first. I hope I mentioned this, but in case I haven't, because this is kind of implied, but maybe it's not clear. Instructions obviously are executed in order. So it's first this instruction and then this instruction. So now if we create the token, there we go. That works. And just like that, we have created a token with 9 decimals where we are the authority. Easy. Now where it gets a little bit more complicated is creating the token account, especially if you want it to be an associated token account, which I recommend that you do. Working without associated token accounts is a bit weird unless you're within your program and you know exactly what you're doing. Maybe it's a PDA from your program itself or something. Then I would say, yeah, it's fine. But if you're creating it for a user wallet, in 99% of cases, you do want it to be an ATA. There are special cases where you might specifically want it somewhere else. But in our case, let's say we want to create an associated token account. So we do want the associated token program to do the account creation for us. So basically, now we just tell the associated token program, hey, please create the ATA for us. And then it does all the CPIs to the system program and to the token program. And that is done with a get create. So here it is actually called create associated token instruction. This one. This one takes the ATA, the mint, the owner, the payer, system program and token program. Let's start with the simple things. Payer is gonna be my key pair. Owners, who do we create it for? A new receiver. Maybe let's create a keeper for that guy as well. This is just to showcase some stuff. So I'm gonna log stuff and I'm gonna log as well. I'm gonna log the mint address. I'm gonna log the receiver. If you're doing something like that, maybe you do want to store the private key here as well, but don't log private keys. This is just as an example. In a productive environment, I would load my receiver from an environment variable or something. Okay, so the owner will be the receiver. Now, the mint should also be fairly clear. That's the address of my mint account. And now the really interesting part is the ATA. Where do we get that from? That we need to derive. And we could do it the same way as we did here when we created the PDA for our program, with this get program derived address. So something like this. Or there is also a function for that, get associated token account address. Oh, by the way, gil/programs exports all of the program stuff so that you don't need to import all of the programs. like I did here, but I just like to show you where they actually are. So basically, I could get rid of that and import all of the missing things from guild/programs. Anyway, so get associated token account address, ATA address, needs the mint, the owner, and the token program if it's not token keg. So that's simple. The mint address and the owner, which is my key pair. So it's also this owner. It's the authority address. Like this, we can get the ATA. But I do want to tell you what this does internally. So we're going to do a second one. I'm going to do a compare to this. Because what's behind that really is just get a PDA for the associated token program with the seeds. And I'm not sure if I'm getting them in the right order, but it was the mint, the authority, the owner, and the token program, although I'm not sure in which order anymore. So let's quickly check. Let's quickly try. That's the authority. I think before that was the mint, and after that the token program. Like this, with those seeds, I think you would get to the same ATA. Let's quickly check. Nope. Maybe the token program. Okay, I quickly checked. It's first the wallet for which the token is created, then the token program, then the mint. That's the right order. Okay, then we get the right ATA or the same ATA. And this one still gives me the bump as well. So really, I just need this. But anyway, that's just to check. That's just to compare. This is how you would do it manually. There is this nice function. I just want you to understand what this does, is that is creates a PDA with the seeds of the wallet, the token program, and the mint, because that's what we saw that this depends on. The ATA depends on the mint, the wallet that it's an ATA for, and the token program, because if we have a different token program, we still need to make sure that it's a mint of this token. So that's why definitely the token program is also relevant and is just part of the seeds when creating this PDA. And we create this PDA for the associated token program. So that's why that is also in there. But the associated token program is always the same, no matter the token program it uses. Complicated? Yes. But if you get it, you get it. Okay, now that we have the ATA and we can create this associated token instruction to create the ATA, create ATA, we just put that in here as well. And then while we're here, we might as well create a mint instruction. So get mint 2 is what it's called. Wait a second. I was already one step ahead. Forget what I did here with the receiver. I wanted to create for someone else. Obviously, we created for our own key pair. We're still in the process of creating the token, not of transferring it. Sorry, my bad. Forget what I did here. We then also first mint to us, and then later we can do transfer. So get mint to instruction. Let's go with a get mint to instruction, which takes the amount. And now here we're dealing with actual numbers. So here we're one level lower, if you will, where it's like we're more being developers and less being users. Here we need to provide the amount in actual number of tokens considering the decimals. So if we want to mint one token that has 9 decimals, then we need to add 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. And because that looks like shit, I'm gonna write it like this. That would mint us 1 token of that mint, and we are the mint authority, my key pair, and token, that is the token account, that's gonna be the ATA. We're gonna mint into my ATA. And then I just add this instruction in here. And then we have all of those instructions in one transaction, and then we can neatly just create a token and already mint some tokens all in one, except the initialize mint doesn't work. Hold on, what are we doing? Instruction modified an account that it doesn't own. Oh, did they change the default to token extensions? That's new. So apparently when we say we initialize mint. Oh, I got that. Oh, hold on. Because we imported that from Gil programs, it's a bit of a problem because both token programs have the same instructions and therefore they have the same instruction names. So I will specifically import that from token such that I can make sure that it is actually token keg and not token z. It's just one downside of working with Gil. If we use the token program, use Solana program token, then we're safe, because otherwise Gil exports all of them and therefore this doesn't work anymore. Okay, cool. Now this should work again. Associated address does not match seed derivation, so we are not providing the correct ATA. Because maybe also that was done for the different program address, or here we might have the different token program as default. So let's put in this token program, the token keg. I said it's easy. Yeah, then we get incorrect program ID for instruction. Oh, you mother. This is just annoying. You know what? I don't enjoy Gil anymore. Besides, we're day 5. We don't need Gil anymore. We can just use regular Solana kit, or at least I'm gonna get rid of the Gil programs. I'm gonna keep Gil node, but I'm gonna again import everything from Solana program. Oh, okay, so interesting. I didn't even know that before. Gil has Gil programs and then Gil program / token for the token program, and in programs is apparently the token 2022 program. So I would have specifically to import them from Gil programs token. Interesting. Okay. If we import from Gil / token, then it's a... Nope, that's still from token Z. What? That's token. That's still wrong then. Screw that. Okay, now I have everything from Solana program token. Then that should hopefully work now. Yeah, there we go. I said it's great because there's just one token program on Solana. What could possibly go wrong? That we introduced a second one. Oh yeah, we did that. And now it's maybe a bit more confusing and a bit more challenging technically to get them right and use the correct accounts. But once we use the correct accounts, this is actually quite straightforward with this nice little helper of the associated token program create instruction. It puts in all the right accounts and instruction data to create this PDA that we can then in the end directly mint tokens to one token. And you also see in the Explorer the change of tokens. So that is the mint we created and that's the ATA. So in this ATA for this mint, we got one token. Nice. So that's how you do it programmatically with TypeScript. And I think that's good enough for you to get the gist of it. I am of course going to give you homework because the next step from here is obviously to do a transfer of tokens. So as a homework, you create yourself a token with Gil or the kit or even just the CLI if you need to. So you can use this script as well. It will be on my GitHub. And then I want you to do a transfer of this token or a few tokens to some other ATA of another account. See what you need to do for that. And do it really programmatically like this where you manually do the instructions, because that way you can make sure that you really understand it. What are the accounts that need to be involved? Which accounts do I still need to create? Hint, you will need to create the ATA of the receiver unless that already exists. Yeah, and then you can transfer tokens back and forth. Maybe send them to a wallet that you have in a browser extension. Or if you feel ready for it, create a token on mainnet. It's the exact same, just that it's on mainnet. So the procedure is the exact same. Obviously, mainnet and devnet are not the same things. Yeah, and I think that's good enough for today. We did learn about what tokens are, and we do understand all of the accounts that are involved. Tokens are fun. Tokens are a reason why people come to Solana. Tokens are a reason why people leave Solana. Tokens are just one of those, how do you say, like building blocks. And so it's crucial that you do understand how tokens work on Solana. Otherwise you will have a very hard time as a dev. So yeah, good that we went over this today once again. And obviously this is by far not everything that we could talk about when it comes to tokens. There is the entire Token 2022 program with all of its extensions and features and stuff. And even token keg has a few more features that we didn't get through. And then there's the whole side of how do we work with tokens inside our programs, basically through CPIing into the token program or the associated token program. But there are helpers for that as well. Tomorrow, we're gonna build another program, but this time not with Anchor. And the real topic of tomorrow is gonna be serialization and deserialization. Because as I already teasered today, most of the things on Solana is just a bunch of bytes. Because machines are just good at working with that. So really understanding how the data is stored and how instructions and transactions are really serialized will help you as a Solana dev. That's why that's gonna be the last big content block tomorrow. And then we have one last day where we wrap it all up in this series of how to get started with Solana development in 2026. I hope you enjoyed. If you do, leave me a like, subscribe if you haven't done that yet. Check out my other videos. I do a lot more than just this basic stuff. And yeah, I'll see you back here tomorrow, fresh and early for day 6. Till then, good night, sleep well, and play around with tokens on Solana.